Okay, so let's simplify this radical. This one actually has three factors, a coefficient, so I'll break it up into square root of 96, a variable, x to the fifth, so I'll have an x to the fifth factor, and a y to the 18th, so the y to the 18th. So what I'm going to do is I'm going to look for the coefficient, I'm going to look for a perfect square that's a factor of 96. I'm going to look for the largest one. So let me see, perfect squares, for instance, like 4 goes into 96, but 4 might not be the largest one. So I'm going to look a little bit further. Let me see, 9 doesn't go into 96. 16 does go into 96 also. 16 goes into 96, and let me see, next one would be 25. 25 doesn't. Next one would be 36. 36 doesn't. And the next one would be 49. 49 is too large of a number to go into 96. So it seems like the winner is 16. Seems like that's the winner. So that's the one I'm going to use to factor the square root of 96. And the third will be whatever the other factor is that I multiply by 16 to get 96. The square root of that number will be the third. So I'm going to break this one up. Instead of just 96, I'm going to write it as 16 times some other number. And it turns out that 96 is 16 multiplied by 6. 16 times 6. The next one, I'm going to do a little long division to figure out how to break that one up. I'm dividing 5 by 2. So I'm dividing the power, which is 5, by the index, which when there's no index written, we assume that the index is 2. So if I divide 5 by 2, I get 2. 2 times 2 is 4, and the remainder is 1. So I'm going to be using these numbers, 1 and 4 and 2. I'm going to use those numbers when I do this simplification here. So, for instance, when I break this thing up, it's going to be the square root, and the one that's going to be a rational power of x is x to the fourth, x to the fourth. But then I have to multiply that by x to the first. So that's where the 4 plus the 1 is going to equal the 5. Because x to the fourth times x to the first is x to the fifth. So I have that one. And then I'm going to do long division on the other one too. Let's see, y to the 18th. So I'm taking 18 and dividing it by 2. So 2 goes into 18 9 times. 9 times 2 is exactly 18. And this one leaves no remainder, which is good. That means that the whole thing can actually be simplified into just a rational power of y. So now I'm going to break these things up. Let me see. I got the square root of 16. I know that's a rational. I got the square root of 6, which is a third. I got the square root of x to the fourth, which I can simplify. And I have the square root of x to the first, which cannot be simplified any further. It's simplified all the way. And finally, I have the square root of y to the 18th, which can be further simplified. All right, so what I'm going to do now is I'm just going to go through and I'm going to group all those red ones, the ones I know I can simplify further, like the square root of 16. That one I know is just 4. And the square root of x to the fourth, I'm going to write it as the square of some power of x. And all I have to do to figure out what that power of x is divide 4 by 2, and I'll see that that's going to be x squared. And this last one, I'm going to write it as the square root of some power of y squared, and the power is going to be whatever I get when I divide 18 by 2, and that's going to be y to the 9th. The other two factors, the square root of 6 and the square root of x, I'm just going to combine into the square root of 6x. So the two that cannot be simplified any further, I just put under one radical. Then I'm going to go through and simplify. The square root of 16, like I said, is 4. The square root of x squared squared, well, the square root and the square will cancel, the outer square, but it still leaves the inner square. And because it's an even index, I put the absolute value. And then this one here is the square root of y to the 9th squared, so the square root and the square power cancel, and I get here the square root, or the absolute value of y to the 9th. And then lastly, the square root of 6x, which I can't simplify any further. Now, looking at each of these individual variable factors, the absolute value of x squared, since I'm squaring x and x is a real number, I know that x squared is positive, because when you square a real number, it's always positive. So you don't need the absolute value for the x squared, because x squared is always positive. Y to the 9th power, on the other hand, well, y to the 9th power could be negative if y itself is negative. And since we don't know the sign of y to the 9th power, because it depends on if y is positive or negative, we cannot get rid of the absolute value with the y to the 9th. So we have to keep the absolute value of y to the 9th, and then we'll have the square root of 6x that cannot be simplified any further. So this would be our final answer, and this would be what the computer would be looking for.